Hi, this is Mrs. Nearing, and in this video we're going to talk through some stoichiometry problems. This is the Super Stoich practice set. So I've got a screenshot over here of my stoichiometry mole map that we made from earlier, and we'll refer back to this as we go through problems. So problem number 1, it's asking me how many moles of aluminum I need to react with 9.8 moles of oxygen. So my first step in this type of problem is always to write down what I am given. So I'm given 9.8 moles of O2. And then when I'm doing dimensional analysis here, the units that I have should go on the bottom. So I'm going to put moles O2 on the bottom. Notice I'm not putting in any numbers yet. And then what I want goes on the top. I want moles of aluminum. And if you look over here at my mole map, I'm right here. I'm going from moles A to moles B. So it's a mole to mole step. And the way that I convert from moles of one thing to moles of something else is to use the coefficients from my balanced chemical equation. So if I look up here in my chemical equation, I can see that for every 4 aluminums, whoops, I forgot my L there. For every 4 aluminums, I need 3 oxygens. So it's a 4:3 ratio. So if I'm going to go through and plug this in my calculator, I'm going to go 9.8 times 4 divided by 3. I'm going to end up with 13.07 moles of aluminum. All right, so that's how many moles of aluminum I need. Let's go on the next problem. So I want how many moles of aluminum oxide will be made if I react 5 moles of oxygen gas. So again, first thing, I'm going to write down the number I'm given, 5 moles of oxygen gas. And I'm going to think about my ratio here. So the units that I have are going to go on the bottom, moles of O2. The units that I want go on top, moles Al2O3, and to figure out what numbers go there, I'm going to look at the coefficients from my chemical equation. So it's 3 oxygens for every 2 aluminum oxide. So it's a 2:3 ratio, so my calculator, 5 times 2 divided by 3, I end up with 3.33 moles Al2O3. I'm just going to round everything to the hundredths place for this. Okay, this next problem, I'm going from grams to moles. So if I look at my mole map, if I'm going from grams of one thing to moles of something else, that is going to be a 1-2-step process. So here I'm starting with 123.5 grams of oxygen gas, and I want to find moles of aluminum. So I'm starting over here, grams of O2, and I'm trying to get to moles of aluminum. So my first step is to go from grams of O2 and convert that into moles of O2. So the unit that I have, grams of O2, is going to go on the bottom. The unit that I want, moles of O2, goes on the top. And the way that I find this conversion is I look at the periodic table for the molar mass of O2. So if you look on the periodic table, 1 mole of O2 weighs 32 grams. That's because there's a 2 here, so I have to add up the masses of 2 oxygens. That's where the 32 comes from. All right, so now I'm at moles of O2. My next step is go from moles of O2 to moles aluminum. So the unit that I have, moles of O2, goes on the bottom. The unit that I want, moles of aluminum, goes on the top. And if I'm going to look at my chemical equation, it looks like for every 3 moles of aluminum, I for every 3 moles of oxygen, I need 4 moles of aluminum. And if I stop and solve here, notice my grams cancels out, moles cancels out, I'm left with moles of aluminum. So when I plug that in my calculator, it's 123.5 times 1 divided by 32 times 4 divided by 3, and I should end up with 5.15 moles of aluminum. So that is a moles to grams problem. Let's scroll down and try a grams to moles problem. And with grams to moles, in this case, I'm starting with 11.1 moles of aluminum oxide. And I want to go from moles of one thing to grams of something else. That looks like that is a 1-2-step problem. So I'm first going to go from moles aluminum oxide to moles aluminum. Then I'm going to go from moles aluminum to grams aluminum. That's my 2 steps. So my first step, units that I have go on the bottom. so moles Al2O3 on the bottom. Units that I want, moles Al, goes on the top. And if I'm going to scroll back and look at my balanced chemical equation, for every 4 aluminums, I can make 2 aluminum oxides. So for every 4 aluminums, I'm going to make 2 aluminum oxides. That's my first steps complete. Check. Okay, now I'm going to go from moles of aluminum to grams aluminum. This number I find by looking on the periodic table, and if I look on the periodic table, I see 1 mole of aluminum weighs 26.98 grams. Okay, so then I'm going to stop and plug that in my calculator. 11.1 times 4 divided by 2 times 26.98, and I end up with 598.96 grams of aluminum being made there. All right, let's try a grams to grams problem. So this is going to be a 3-step problem to go from grams to moles, moles to moles, and then moles to grams. That's 3 steps. So I'm starting with 249.4 grams of aluminum, and I'm trying to find grams of aluminum oxide. So let's map out my steps here. I'm going to go from grams aluminum to moles aluminum. That's step 1. Then moles aluminum to moles aluminum oxide. That's step 2. And then my last step, go from moles aluminum oxide to grams aluminum oxide. Okay, so step 1, grams aluminum to moles aluminum. I'm going to look on the periodic table. 1 mole of aluminum weighs 26.98 grams. Next step, I'm going to go from moles aluminum to moles aluminum oxide. And if I look back at my chemical equation, I need 4 aluminums to make 2 aluminum oxides. So 4 aluminums to 2 aluminum oxides. And then I'm going to go from moles aluminum oxide to grams aluminum oxide. And to find this molar mass, I'm going to take the mass of 2 aluminums, so that's 2 times 26.98, and add it to the mass of 3 oxygens. So I have to plug that in my calculator real quick. So 3 times 16 plus 26.98 times 2, and you end up with 102 grams. So this is 102 grams. Okay, so now I'm going to stop and plug this all in my calculator. Notice grams aluminums cancel, moles aluminums cancel, moles aluminum oxide cancels. I'm left with an answer that is in grams aluminum oxide. So I'm going to take 249.4 times 1 divided by 26.98. Whoops, hold on, I typed that in wrong. 249.4 minus 26.98. Times 2 divided by 4 times 102, I should end up with 471.44 grams of aluminum oxide. That's what it looks like there to me. So we can see with these stoichiometry problems, use your mole map as a guide to help you out. They're either going to be a 1-step problem or a 2-step problem or a 3-step problem. But notice whatever type of problem that they are, there is always going to be a mole-to-mole step in there somewhere. So at some point, you're always going to look back at the chemical equation, which makes sense because remember, our chemical equation is like our recipe here that tells us how this reaction works. So you should always be using this information at somewhere in your problem. All right, let me know